Hi everyone, welcome to this episode of Carpet Labs. In this video we're going to be talking about the concept of energy accounts, an analogy that we can use to help us talk about energy in chemistry. We're going to go through a little bit of some definitions about energy. We're going to talk through some of the characteristics of energy, or how we discuss energy to be like. Talking about an analogy that might help us to understand what energy is and isn't, and kind of how that works. Introduce the idea of energy accounts in a system, and then also look at the concept of energy transfer and how that works. Okay, let's get into it. Okay, so let's start with a definition, or kind of even just kind of a really rough, rough kind of working definition to start with. This idea that this kind of like substance that can cause change. Okay, I use the word substance in inverted commas there very deliberately, because what we're going to talk about here is that energy isn't actually a substance as like matter is, but yet it if we talk about it like that, and that it is this substance-like thing, then that helps us to understand it better. Okay, so some of the characteristics that we might want to consider. Okay, so that it is so substance-like. Okay, and that is can be stored. Okay, so it's like a thing that we can actually store in a system. Okay, so this idea that it can flow or transfer from one system to another, and that's the process that causes change that we would see. But it's something that maintains its identity after it's being transferred. Now, this is one of the ones that it seems a little bit trivial to mention it, but it's actually probably one that is the biggest misconception, is that we tend to talk about kinetic energy becoming gravitational potential energy, becoming chemical energy, as though these are, like they're putting on different hats, or the energy itself is somehow different depending on where it is. But the reality is that energy remains the same regardless of where it's stored or how it's transferred. Okay, and so that's one thing that we do need to wrap our heads around a little bit. Okay, so there's three kind of main characteristics. So something we can store, it's something that can be transferred, but otherwise it maintains its identity. Okay, so we're going to think about this quickly as an analogy. So a way for us to, because energy is one of the hardest concepts to understand. Okay, in science in general, whether it's physics, chemistry, biology, or whatever. Okay, and so we're going to think about energy in terms of information. Okay, so the analogy of it being like information. Okay, so we can say like information that's stored, so let's think about information like electronic information we might have on a USB. So we can store it, so maybe we're talking about a USB, maybe we're talking about a CD or a DVD. We can find places to store it. It can be transferred. Information can be transferred from one place to another. Maybe it's by way of an email, or some sort of other signal, or something like that. That it can be moved from place to place. But and otherwise the information remains the same. So depending on whether it's written down, whether it's typed into a document or whatever, whether we emailed that and it's received on the other end, the idea is that information remains the same. But the thing is, information is this intangible sort of concept, that it's not actually being stored in something physical. Meaning is extracted from something that you receive or that you send, okay? But we can consider it to be stored, we can consider it to be transferred, and then it remains the same during this process. Okay, so that's you use that information to try and help you there. Okay, now we're going to think about this idea, energy storage and energy transfer. Okay, so we're going to think about storage in terms of three. Actually, I'm going to put it up the top here, and you'll see why in a sec. Okay. So when we're thinking about energy being able to be stored in a physical system, in something that's real, in something that is tangible, we think about it, that's made up of particles. We think about it being stored in one of three kind of places, or in one of the three aspects of the system. Okay, excuse me while I change pens for a moment. Okay, so the first one that we think about is thermal. So we call these different energy accounts thermal. Okay. The next, so thermal. So it's to do with when we've got a system made up of particles, it's their motion that it's being stored as. So that energy is being involved in the motion of any particles. We've talked about this idea that particles are always in motion, and that we can look at the link of that with temperature, and so we're seeing that the energy that's involved there does affect how those particles are moving. And so we say it's thermal energy. And so what we're going to use is we're going to use a little symbol, a capital E, with a little subscript TH there to refer to energy that's being stored because of the way particles are moving. The next way that it can be stored, we call it phase energy. Okay? So this relates to the arrangement of particles. Okay? And we're going to give it along the same lines a symbol of EPH. Okay? So that is based on how the particles are arranged together, that there was energy involved in storing in that. Okay? And so what we have is that it's lowest in a solid, it's higher in a liquid, and then significantly higher again in terms of a gas. That is, the closer the particles are arranged, the lower this phase energy, the less energy is stored in this arrangement of particles. Okay, because they get a benefit by being that attraction to one another, by being close. Okay, that has an energy benefit here. Okay, so we have thermal energy for motion, phase energy in the arrangement of the particles, and then also we have chemical. What we would call chemical energy. Okay, so that is in the nature of the particles themselves. Okay, so what we might say is bonding or things like that inside. So it's actually not one particle to another, but actually something intrinsic or something embedded in the actual particle itself. We would give it the symbol of ECH. Okay, so this relates to, do we have, does that particle have multiple parts inside it that are interacting and connected together? Okay, are they different, the same elements or different elements or whatever? We are going to come back and revisit this particular account in unit 6. So we're not going to touch that at all, because this is the one that's involved when we're thinking about chemical change. Okay, so changing from one substance into a different substance altogether. All right, so we're not interested in it at the moment. Okay, so just be mindful of that. All right, but so far in this topic, we're going to be talking about energy stored in the thermal account and stored in the phase account. Okay, last thing that we're going to talk about here is we're now going to start to talk about energy transfer mechanisms. So like how does energy actually get in or out of a system? What are the techniques or the actual the nitty-gritty of the how? Okay, so we've got three main transfer mechanisms that would happen here. Okay, in two of them are only really going to be of interest to us in chemistry, okay, as opposed to in physics. Okay, so we've got working, okay, and then we've got heating, and we've got radiating. Okay, so working, we give a capital W, heating, we give a Q, and radiating, we give R. Okay, heating is not H, because what we'll see is that H actually relates to that chemical energy we were talking about before. Okay, but so these are the ways that energy transfers in or out of the system. Okay, so let's put boxes around these ones, just to kind of highlight them for you. Okay, so heating, so working is kind of like the push or pull. So pushing of macro objects. Okay, so objects at the big level where we're thinking about, so that actually gas is kind of pushing against a plunger to kind of push it out, or a box kind of pushing against a wall or something like that. That's energy that's being transferred by the idea of working. Heating is about particle interaction. Maybe we might even say particle collisions. So that is transfer in terms of their motion. So one particle colliding against another, or one set of particles colliding against another set of particles and transferring energy from that collision. And then radiating is giving off energy in the form of electromagnetic radiation. Okay, so actually giving off waves of light or all those sorts of things. Okay, that wraps it up from here. Thanks very much for watching. So here's the kind of final joke dedicated to you, Ruby. So what do you do with a sick chemist? I'm saying like a Kiwi. What do you do with a sick chemist? If you can't heal him and you can't cure him, you've got to bury him. All right. Thanks very much for watching. Pipe it out.